This morning, I'm going to share our insights into current data center trends and then speak about my own experience around BIM, collaboration, and training. First, I'll share information we put together at FTI regarding the data center market. We have studied the development of the data center space across the region and globe to understand the growth trajectory. Our studies indicate that in the long term, we're looking at a 500 gigawatt industry by 2048. In the near term, we'll reach 236 gigawatt. Currently, a large proportion of existing data centers are in North America and Europe, with a smattering across the rest of the world. Asia currently represents about 30% of global capacity and will see the greatest growth driven by China, large investments in Japan, and AI demands. Development of new data centers in Asia isn't without challenges. Building data centers in APAC is complicated. Land is an issue, power is an issue, water is an issue. We've identified in our matrix which countries are best set up for data centers and which will present challenges. At FTI Consulting, we offer comprehensive services for the entire life cycle of data centers, including investment, financing, tax, and construction. We can get involved in construction feasibility studies, technical studies, and my particular involvement is in technology enablement for construction. I've identified 3 key themes important in data center project development: improving coordination, training people, and establishing monitoring systems. Data centers are incredibly complicated when it comes to fitting out. Because of project speed demands, there's a push for off-site manufacturing, which drives coordination issues. For monitoring, we've seen great examples of using reality capture to monitor projects. This is absolutely essential. If you're running any data center project, you'll likely have overseas clients and engineering teams who need access to the job site. Reality capture is crucial. Many issues revolve around information sharing, collaboration, and communication. While BIM and reality capture are valuable, they're not working on all projects. There's a failure mechanism we must understand, which for me is primarily around training. I don't think we train people properly or provide enough support, causing systems to fall apart. We need to prioritize training and collaboration across the supply chain. From a BIM perspective, it's absolutely necessary to have a common data environment, a shared central location for all information. If you're building any project without the facility to share information between engineers, architects, and contractors, you're doomed to failure. Clash detection is sometimes left to the BIM team, but engineers must be involved in that clash detection and resolution process for it to be effective. The coordination process should be weekly and model-driven. If you're running a design management process in a contractor's office, it should start with model reviews, not last week's meeting notes or Excel lists of issues. The model should be the hub, driving everything through it. This is often called model first, draw second. Too many firms still create drawings first, then generate models afterward, a complete waste of time and money. Clients should be involved in the process. Many times clients specify they want BIM or reality capture, then pass that requirement down to designers or contractors without ever asking about it again. If you want a successful data center project as a developer, you should participate in the process by reviewing models and attending meetings. Reality capture through laser scanning and photogrammetry is brilliant for progress monitoring. Looking at scans week after week shows the progress of works and helps avoid claims and disputes. Models can be shared across the team, allowing problems to be found and fixed more quickly. When you introduce augmented reality, projecting the model into the construction space, it adds another layer of value. None of this is possible without proper training and coordination. To empower teams, you must train them repeatedly. Not enough people are being trained to use these tools. It needs to be all project participants, not just the BIM team. Engineers need training to review models, site teams need training to use 360 cameras, and everyone needs training to access the common data environment. This requires reskilling existing professionals. We don't need to hire many new BIM specialists. We need to upskill the existing architects, engineers, and project managers. This isn't a one-off certification course. It's continuous learning requiring an investment of time and money that must be budgeted into projects. BIM is a collaboration sport, and we must create collaborative environments. We need to consider early contractor involvement. The people who build data centers are the contractors and supply chain. They need to be involved much earlier in the process. Projects need collaborative forms of contracts where risks are shared between owners, engineers, and contractors. Too many clients pass their risk down the chain, causing strife. Within collaborative contracts, there must be clear lines of responsibility. Who's responsible for coordination, detailing, and when engineers hand over their models to contractors? Client involvement is essential. If you set up a collaborative agreement, you need a client who commits to that process. If a client is very traditional, risk-averse, and just wants the cheapest price, this process won't work. Right? This approach is best suited to modern, well-thought-through projects, where clients actually invest in more modern delivery methods. In summary, BIM is only a tool. It doesn't solve all problems. Reality capture is great when combined with BIM. You must invest in training and set up a collaborative environment with strong client leadership. These are my key points. BIM is your tool. Reality capture is a powerful enabler, but you must establish proper training and collaboration.